Welcome back, everyone, to episode 49. I can't believe we made it to 49 episodes, but as usual, there's always new things happening in this field. So we are glad to share the latest things we found out about the state of AI. So before we get started, how are you doing, Balaji? Welcome.
I'm doing great, Rajni. As you can see, I got my own nuclear power reactor. I just bought an island. The tool that's not working, I'm going to commission it. I need all that power for my GPU. I don't know about you. You got your own on the back. Why don't you tell us
I got
about it?
mine in Texas. We got some fancy ones, and it's clean energy. So we represented with white shirt today. So, but it is very. I mean, what we're referring to for people who haven't been following it is almost every company that's in the AI space have realized how much energy needs are going to increase. And just because we buy that, and our reactors are done, but even the small modular reactors are normally just for others, right? Usually it's like 10 to 14 years in the US because of regulations to get something and get it done. But the smaller ones are closer to 4 to 7 years now. But in like countries like South Korea, where they're and China now, they're doing a lot of these modular ones so they can have faster to production. But
Interesting.
the bottom line is just like we talked about. I think we've talked about it at least a year ago. How if you lower the cost of energy, which we have to based on the need we need, to lower the cost of transportation using not robotic, the self-driving cars, when those things go down, I think the use cases are going to be crazy for things we can not even comprehend now. So it's going to be exciting for our kids. Maybe it won't happen in our lifetime, but it'll definitely be very exciting for the new entrepreneurs coming up. So
I agree.
but
Yeah.
stating that, let's jump into. We have a lot to cover. I'm going to try to keep us on track. This is from State of AI report. I think this is the seventh report that came out. We have a lot to cover, so I'm going to try to keep it as rapid pace as possible. And then they have some predictions. So I want us to spend some time on that. So let's start with this. What top those who are interested should absolutely go to their website and read it. What we did was there's like 207 pages of information, very dense information. So we picked things that we have covered in the last 12 months um, in our show, and then there's some supporting evidence or there's some at least some more information about what we've talked about. So those are the topics I kind of teased out of it. So you guys don't have to read the 200 pages, but I highly recommend everybody go read it if you're
So this is
interested in
from
the
the Air
air.
Street Capital, right, Rajni? This report? Got it.
Yes, it is. It's from the Airstream, and I think the website is stateof.ai. So I recommend it. So saying that, let's jump into it. So one of the things we've talked about is that there's always a big model coming, and then immediately another smaller version of it. And we've talked about how's the performance going to be. And now I think the research has shown that it is possible to shrink models with minimal impact on performance. So your thoughts on it?
Quick thoughts. I think this is an ongoing effort. The moment the first models came about, it's a very what do you call it? There's a lot of zeros in the matrix that they are trying to figure out how to get rid of without losing the performance of it, right? So we call it shrinking the models or trying to prune some layers, make sure it's optimal. But at the end of the day, some people blame it as inefficient training leading to this type or the architecture. On the other side, how do we reduce it and shrink it because the size of the model matters to the GPU, right? So absolutely
Correct.
fantastic. Yeah.
Yeah, I think it's good that they're removing some optim or at least they're narrowing it to optimal. I think this immediately goes into our next topic that we can talk about is how is this compared to digital models are becoming more fashionable. And everybody knows Andre is current large models could be a reflection of inefficient training, but the bigger models to refine and synthesize training data could help train smaller models. That's the hypothesis. I know Google has released a small model. Even Llama's released a small model. And if you look at the actual performance, there's not a big difference in performance. So I think we need the big model to create a small model, but I feel like the more we learn about this, maybe we will be creating more efficient models to start with. So this is going to be interesting.
Right. And one thing to note is we created this large language model, right? And then we are picking and choosing what we want to use and training these smaller to become more efficient. It's become an engineering process now, right? But the
Correct.
real question is, okay, so you took something, expanded it, and now you're shrinking it back to smaller size, compacting it for use. That makes sense. It's a compression decompression type of a process here, and the test benchmark tests are a way to verify whether it's actually doing the same thing that the big one did, right? So it's fascinating. Look at how this evolution happens in this setup.
Correct. And I think the smaller the model gets, maybe you don't have to solve the same breadth of problems, right? These small models might be optimized for a very specific problem or a specific industry or what I'm saying. I think that's where the strength of the small models will shine. So
That's
I
that's
think that's
the
what
that's the thing Karpathy is talking about, inefficient training, right? It all lies in what you pick to feed the system to train, right? You can't just, it's still a garbage in, garbage out. You just have to focus more on the data and how you come up with the information to train.
perfect. Let's move to the next one. We're gonna keep this rapid. All right, this is I think is important, so I want to spend a minute on it. This mobile models built for mobile compete with the larger peers. As big tech company, we just talked about large scale end user deployment, but I think when these models are small enough to run efficiently on smartphones is where the most value, because at this point we don't have another interface that everybody has in their pocket. But so if you can make this intelligence available in a small model, be able to available to run in smartphones, I think that's where the most adoption or use cases are going to come from. So I know Huggy Faces, I like the name Small LM, and Microsoft has their own version, Apple has it, and I think everybody's trying to see what is the best one. But so your thoughts on these?
Yeah, my thought is that the edge device, again, we are taking all the things that worked in the past and trying it with the large language model, right? You're trying to push the language model to the edge with some decent capabilities so it can work untethered with the internet if you can, right? So that gives
That's
it some
true.
capabilities, and then when it exceeds that capacity, then you kind of connect to the internet and do other things. So it makes total sense.
And I think this is where some of the devices we've already reviewed, if we could stand alone work, I think it was a pin, humane pin, if I remember right.
Humane pin,
Those
yeah.
things will get a lot more useful if we can make these models work. All right, this one's interesting because we've talked about is at some point we're going to run out of data to train. So synthetic data, I think we've talked about a few episodes back. Last year there was a lot of divided opinion about synthetic data. Some rightfully were talking about, hey, this could cause compounding errors. But I think widespread opinion seems to be warming to the idea of synthetic data is not a bad thing. We will need it to make sure we can train our models the right way.
Right. Synthetic data, we talked about it probably 10 months ago. The synthetic data is an important component in a lot of aspects of what we want to try to do with AI. But there's also this question, open-ended question, right? So models come out, they pass the test, they go into public view, and humans interact with it, and then suddenly you find that it is not as smart as it used to be, right? And the feedback loop of training with the so why I'm saying this is, where is the synthetic data getting generated from? Who is reviewing to make sure that it covers all the edge cases or whatnot, right? And then you feed it into the system, and then how long does it last there with the feedback loop from the user? This is one of the things that is actively being researched, right? It's almost like a human. As you age, you lose your memory capacity type of thing. As the model ages, it becomes less and less intelligent of sort, according to the benchmark, right? So